Hi everyone, I'm Pat.
I'm Owen. I'm Surya.
And today we're going to talk about our new MiniDrone project, which has a focus on education and testing. So, why do we make it? Developing a self-driving car is a difficult and expensive problem. So we've taken inspiration from other projects such as Donkey Cars, F110 and NVIDIA's JetBot. We have two main goals with the project. One is to provide an education platform and the other to provide a testing platform. Our team is primarily comprised of undergrads. Before they can start working on the full-scale vehicles, there's a steep learning curve they have to overcome. They have to learn about software, sensors and hardware, as well as integrating all this together. The MiniDrone provides a platform for new members to learn in a hands-on and approachable way.
So the MiniDrone was designed to be a small-scale version of the street drone. This allows us to test at a small scale, which also allows us to quickly prototype and test different ideas. This is our current prototype. It contains a computer and a sensor suite, which collectively is called the box, and it sits on top of a stripped down RC chassis. We've been able to make a few iterations already, and by being able to use off-the-shelf hobby components, we've been able to experiment with different designs and make multiple vehicles to test with.
As mentioned earlier, we've designed the box to be as close as possible to the sensor suite of the street drone. It includes cameras, a GPS and an IMU, all connected to a Jetson Nano computer. We also have the ability to mount different sensor configurations, such as a LiDAR. Although these components aren't automotive grade, they let us imitate closely the setup and data for our software. For the current prototype, we've taken the chassis of an RC car, we've stripped out most of the electronics, and we've mounted our components on the top. So we have a modular rail system that allows us to attach and remove the box and other components as we need. Our hardware team is designing and constructing the entire chassis, body and power system from scratch, which will be larger and more robust. This will provide more options for mounting and make for a more realistic vehicle.
Because the box is a self-contained system, it allows us to detach it from the chassis and test in isolation. It can also be put in any road vehicle, which allows us to gather data and test our software in roads.
Creating the MiniDrone has taught us a lot, and it has already allowed us to approach problems differently and test things more easily than we could before. These include things as fundamental as synchronizing data and establishing connectivity between multiple vehicles, to more fun things such as driving the vehicle with a PS4 controller. One of our next steps is creating educational material to go along with the MiniDrone that focuses on the entire stack. We will continue to develop both the box and the MiniDrone and share updates here.
We hope the MiniDrone will provide a low-cost approach to developing and learning about autonomous vehicles. The best part about the project is that we're going to be open sourcing everything, from the software to the hardware to the CAD files and any other designs. If you'd like to follow along or contribute to the project, we'd love to have you.